Now, you have a problem with chemistry, paper 2. No problem. Here is your teacher, Teacher Zamalek. I'm here for your sake. Let's dive to chemistry, paper 2. Questions? So this is a theory paper. As you always know that we have paper 1, paper 2, and practical. So this is a theory paper, paper 2. Questions? Always paper 2. They are continuous questions. You can see from number 1. The questions continue up to H, and then we'll dive to the next question. So in paper 2, they're kind of continuous and they are structured in that manner. So let's dive to this paper. The grid below shows part of the periodic table. So we have the periodic table. Study it and answer the questions that follow. The letters are not the actual symbols of the elements. So we are told that these letters you're seeing A, B, C, D up to H are not the actual symbols for these particular elements. So this periodic table, we know that periodic table has group 1, group 2, group 3, group 4, group 5, group 6, group 7, and lastly group 8. So these are the groups we have within the periodic table. So groups. How are groups identified? Groups are identified by the electrons in the outermost energy level. So, e.g., if you want to know that this particular element A is in which group, we are going to look at, since we have written the groups up here, it is just group 3. But now, if for instance, an element is given by the electron configuration 2, 7, 2, and we want to identify the group to which this particular element belongs. So we're going to look at the electrons in the outermost energy level, group 2. So it therefore means that the periods are how many? 1, 2, 3. So for you to identify period, we're going to look at the energy levels, the number of energy levels. The number of energy levels gives you the period. So for instance, this particular element with the electron configuration of 272 is belonging to which period? Period 1, 2, 3. So periods are from here 1, 2, 3, 4, 5. So they run from up to down. The groups run from left to right. Are you getting that? Periods run from north to south. I hope we are together. So period, this particular element belongs period 1, period 2, period 3. Which group? Group 2. So the element is F. And I mean, it should not be 2 to 7. It should be 2, 8, 2. Because the rule of electron configuration says the first energy level must be occupied by 2 electrons, holds a maximum of 2 electrons. The second holds a maximum of 8 electrons, depending on the number of electrons that particular atom has. So because this particular atom has 2, 8, 2, we are going to check the 2, group 2, and period 1, 2, 3. So it is this one. That's how we're going to identify this particular element. We want to identify element A. Element A. Element A belongs to which period? Period 1 to period 2. So group is group 3, period 2. So that is the electron configuration. If you want to identify that of B, B group 5, I mean group 6, sorry. B group 6, period 1, 2, 2. So that is how we're going to identify these elements. So let's dive to the questions. Give the name of the family to which element F belongs. So element F we have identified, and we have said element F is this one. It belongs to group 2. Group 2 elements. Group 2 elements. These elements are referred to as alkaline earth metals. Group 1 elements are referred to as alkali metals. Alkali. So alkaline earth metals. So F belongs to a family known as alkaline earth metals. Good. Next question. Identify an element which forms a stable divalent anion. When you talk about an ion, this one are negatively charged, negatively charges, negatively charged. So an ion is negatively charged. The difference between an ion is cation, which is positively charged. So for instance, I have -2, +2. This one is cation and this one is anion. So we are going to identify di means 2. So those particular element with two negative charge, that is what we call a divalent anion. So let's dive to the periodic table. So within the periodic table, we have elements A, B, C, D, E, F, G, and H. So because we have said that for that particular element to be a di means it has 2 electrons within the outermost energy level. Either, because it is an ion, it has to gain 2 electrons. So an element that is going to gain 2 electrons in the outermost energy level, outermost energy level, that element that is going to gain 2 electrons is the one that is going to have a stable divalent anion. So let's see. A cannot gain 2 because it has 3 electrons in the outermost energy level. B is in group 6. It is going to gain 2 electrons. So B ion is going to be written this way. So this is the divalent anion I'm talking about. So the ion of B, for it to form a stable anion, it has to gain 2 electrons. So when atom gains, they have a negative charge. When atoms lose, they lose by a positive charge. So what do we write here? Divalent anion. B is the element. Gains 2 electrons to become stable. And the question has not told us to explain. Just come and identify. Just write B, element B. So just come and write element B. Give the formula of the compound formed between A and B. So A belongs to group 3, period 2. So therefore means A is going to be written with a 3 positive charge. Let's go to the next one. B, electron configuration of B is what? 2 to 6. So it is going to gain 2 electrons. We can write it -2 or 2 negative. So B is going to gain 2 electrons. So when we want to write the compound form, A, 3, B, 2. When they interchange, we're going to have A2, B3. This is the compound that is going to be formed. That is the compound that is going to be formed. The sulfate of H belongs to this one here. H belongs to group 1, period 5. So groups will always give us the charge. So it is going to have a positive. It is going to lose 1 electron, H, because it belongs to group 1. So it's going to lose 1 electron. Sulfate is written that way. So when these charges are interchanged, we are going to have H2SO4. So this one is the compound. This one is the compound formed. This one is the compound formed. H2SO4. Yes, next question. Using dots and cross diagram, show the bonding in the compound formed between E and C. So let's go back to the periodic table. E. Which compound is that? So it belongs to group 1, period 3. So group 1, period 3, E. Group 1, period 3, 1, period 3, 2 to 8 to 1. So which particular element is this? Sodium, with 11 electrons. And then C, back to the periodic table, C is this one. It belongs to group 7, period 2. Group 7, period 2. So C, we're going to have 2 to 7, group 7, period 2. So which element is that? Fluorine. So the kind of bonding is ionic bond. Ionic bonding. So the kind of bond that is going to be formed between the two is an ionic bond. So sodium and fluorine form a compound as they bond using the bond referred to as ionic bonding. That is, the particles, I mean, the kind of electrons are going to be shared. The electrons are going to be shared between sodium atom and fluorine atom, bringing what we are referring to as ionic bond. Ionic bond is a bond formed when atoms, two or more atoms, share electrons. So in this case, they're going to share. So in such a way, one of them is going to donate, sodium is going to donate 1 electron to fluorine, so that fluorine becomes stable and sodium remains stable. Remember, sodium is having an electron configuration of 2 to 8 to 1. So it is going to lose this 1 electron, loses 1 electron. And then fluorine is 2 to 7. Fluorine is going to gain 1 electron. Gain 1 gain. Are you seeing that? So that is kind of bond that we're going to form. So let's dive to the bond. Let's dive to the bonding. I hope you are getting the concept clearly. We have just said that the bond that is going to be formed between E and C, since we have gotten the electron configuration of both the two, and we have known that E is sodium and C is fluorine, the kind of bond that is going to be formed between those two is referred to as ionic bond. Are you getting that? So they're going to form a compound using an ionic bond. And the compound that is going to be formed when sodium and fluorine reacts is referred to as sodium fluoride. Are you getting that? Sodium fluoride. So fluorine is a halogen. A halogen means a group 7. It belongs to group 7, halogens. Halogens are, halo means salt. So they react by forming salts. Sodium fluoride. Sodium is a metal, group 1. Sodium belongs to group 1. And that is why you are seeing E here within this period, group 1. It is a metal. It's a very, very strong metal. So let's dive. We have said, so let's give the electron configuration, the sodium atom, electron configuration, and fluorine atom, electron configuration. So sodium atom, we begin with the nucleus, followed by the first energy level with the 2 electrons, followed by the second with 1, 2, 3, 4, 5, 6, 7, 8, and lastly 8 plus 2. 8 plus 2 is how many? 10. 8 plus 2 is 10. So therefore means that we have remained with 1, 10, 11. Because sodium is 2, 8, 1. So that is the atom, sodium atom. So fluorine atom, electron configuration of fluorine, the nucleus then followed by the first energy level with 1, 2 electron, followed by the second energy level with how many? 7. 1, 2, 3, 4, 5, 6, and lastly 7. So this is fluorine atom. So it has 2 to 7. That is the electron configuration. Let's go to the bonding now. The ionic bonding. The ionic bonding. So let's go to the ionic bonding. We're going to have because sodium is going to lose 1, we're writing plus there. So let's go. The nucleus, the first energy level with how many electrons? 2. And the second energy level with 1, 2, 3, 4, 5, 6, 7, 8. So it is going to lose 1 electron so that it remains stable. It's going to be 2 to 8. This is sodium ion. Sodium ion. So remember, a compound is going to be formed, sodium iodide, fluoride. So fluorine is going to be here. Remember, fluorine is gaining. Fluorine is gaining. So we are going to have a negative here. When it gains, it's going to have a negative. When it loses, so the first energy level with how many electrons? 1, 2. The second energy level with 1, 2, 3, 4, 5, 6, 7, and the last 8 should be the one gained from sodium. And that is why I'm replacing the last one with a dot. Are you seeing? So this is the bond. This is 2 to 8. This is fluorine ion. Fluorine ion. Are you seeing that? So this is the bond. This one here. This is the ionic bond. This is the bond in the compound formed between E and C. So this is the bond. Are we together? So because of space, I'll rub. You can easily copy. You can play the video as many times as you want, so that you understand. So I've just written the atoms, shown you the ionic bonding. I have just showed you the ionic bonding. So in that case, we have 1, 2, 3, 4, 5, 6, 7, 8 for sodium, 9, 10 for sodium ion. And then for fluorine ion, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, again 10, because it is going to gain 1 electron from sodium. So this 1 electron that has been lost by sodium is going to be taken to fluorine. So it is going to transfer electron. So when a particular atom transfer electron to the other atom, that is called ionic bonding. It forms ionic bonding, the transfer of electrons. So in that case, that is the ionic bond formed between the two. So allow me clean this particular space for the next question. Allow me clear this place for the next question. So I think that space is enough. Compare the atomic radius of element C and D. Explain. Back to the periodic table, C and D. An insight we can get from C and D is that they belong to the same period, period 2, and different groups. So we know that across the period, comma, the atomic radius decreases across the period. Why is the atomic radius decreasing across the period? So you realize that across the period here, 1 electron is going to be added to this element D compared to element C. And when electrons are being added to the outermost energy level what happens is that the nuclear forces of attraction is going now to increase, pulling electrons from the outermost energy level towards the nucleus. And when such pullings happens, remember that force is very strong. It pulls the electrons towards the nucleus. When that pulling happens, it reduces the atomic radius. Now, for instance, I have elements like that C and D. C belongs to, so let's say C, it belongs to group 7, period 2. That D belongs to group 8, period 2. So whenever I'm drawing 1, 2, 3, 4, 5, 6, 7. So this is C. And D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. D to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is D. So what we know is that they have the same energy levels. Remember, what is atomic radius? Atomic radius is the distance right from the nucleus to the energy level, the electrons to the last energy level. So the distance from the nucleus here to the outermost energy level, that is what we are referring to atomic radius. So whenever we have an atom with a nucleus and energy levels, that distance from this nucleus to the outermost energy level is what we are referring to as atomic radius. So in that case, let's dive back to the question. We have seen that both C and D, they have the same energy levels. And what is the difference between C and D? The difference comes in the electrons. Electrons of C are few compared to the electrons of D. And for us to know which one has the greatest atomic radius than the other, we are going to check at the number of electrons in the outermost energy level. So we realize that those with higher number of electrons within their outermost energy level experiences greater pull of electrons towards the nucleus. And when the electrons now are being pulled towards the nucleus, there is reduction. There is, reduction of the atomic radius. So the atomic radius is being reduced, being limited to a smaller size as compared to the one with a few electrons. So that is what happens. So for us to explain, let me compare first and then explain. That is what the question wants. Compare the atomic radius of, or atomic radii of C and D. Explain. Radius when it is 1. Radii when there are 2 or more. Are you getting that? So that is the plural. Atomic radius is the distance between the nucleus, the distance from the nucleus to the outermost energy level. That is what we are referring to as atomic radius. So in this case, I'm going to explain this way. We are going to say C has greater atomic radius, because it is now 1, atomic radius than D. So C has greater atomic radius than D. That is 1 mark. Explain. Now we have to say that C and D belongs to the same period. Full stop. Stronger forces of attraction pulls the electrons in the outermost energy level towards the nucleus, reducing the atomic radius, of D because of the increased number of electrons, which increases nuclear forces of attraction. So I have just explained it in broad terms. If you want it in simpler terms, contact me, or let me just explain it. So we can say C has greater atomic radius than D, full stop. That is one mark. Why is that happening? Because of stronger forces of, because of stronger nuclear forces of attraction that pulls the electrons of D towards the nucleus, reducing its atomic radius. Just like that. So we have realized that they belong to the same period. And I began by saying, across the period, the atomic radius decreases because of the increased number of electrons. So as the number of electrons increases, there is greater pull or greater nuclear forces of attraction that is able to pull the electrons towards the nucleus. So the higher we go, the more electrons we have, the increasing number of electrons increases the nuclear forces of attraction, pulling the electrons towards the nucleus. And that is the explanation. So we can say they belong to the same period. Increased number of electrons of element D increases the nuclear forces of attraction, pulling the electrons of D from the outermost energy level. That electrons from the outermost energy level are being pulled towards the nucleus. And when electrons are being pulled towards the nucleus, the distance from the nucleus to the outermost energy level reduces. That is why it is having less atomic radius as compared to C. Are we there? Yes. So that is what happens. So because of space, again, I'll clear my board from this end just to leave the space for F. Remember, this pen is writing in large so that you can easily see, and that is why it consumes a lot of space. Select the element that has the lowest ionization energy. Explain. Back to the diagram. The one with always the lowest ionization energy. Ionization energy is the minimum amount of energy required. Minimum amount of energy required to remove electrons from the outermost energy level in its gaseous state. That is what we are referring to ionization energy. Are you getting that? So it is the minimum amount of energy required to remove. So which one has the minimum amount of energy required because of the less strongly attraction? The less strongly attraction. The one that is, now I began by saying that element, those in group 1 or having the largest period or the ones with the highest period as the lowest ionization energy. So it is the farthest. The one that is the farthest has the lowest ionization energy. H is the one with the lowest ionization energy. Now explain. We have said that it is the farthest from down left. So this is the down left element. So it is the farthest from down left among the elements, sorry, among the elements. So you can easily see among the elements, it is the one among the elements. Let me just clear this area so that it looks neat. Among the elements. So it is the farthest from down left among the elements. You can see H, it is the farthest. So we say its outermost electron, which is just one, is less strongly attracted towards the nucleus, hence less to remove. I mean, less energy, hence less energy required to be removed, hence less energy required to be moved, to be removed, sorry, to be removed. Just like that. So we have seen that it is the farthest. And its outermost electron, or its electrons in the outermost energy level, is less strongly attracted. It is less strongly attracted towards the nucleus, hence less energy required to be removed. The one that is less strongly attracted, or the one that is weakly attracted towards the nucleus, is having less energy. Is having less energy. G. 0.081 gram of element A. Element A is up there. Element A is this one. This one. It belongs to group 3, period 2. Yes. So A reacts with hydrochloric acid. What is our product? Because the ion of A is 3, it is going to form A chloride like this, plus hydrogen gas. So this is a gas, this is an aqueous solution, and this is also an aqueous. A is solid because it is a metal. So this is the reaction. Let's see whether it is balanced. So for the space in between, let me put an arrow just like that. So let's see if it is balanced. 1A balanced, 1H, 2H not balanced. Chlorine are 3. Chlorine are 1, here they are 3. So what if I put 6 here and I put 3 here? Hydrogen will be balanced. Chlorine 6, 3 times 2. Chlorine 6. Hydrogen 6. Not. Let's begin with hydrogen 6. 3 times 2, 6. True, balanced. 6 chlorines. And here we have 3 molecules of chlorine. So when I put 2 here, I'm going to have 2 times 3, 6. Balanced. A, not aluminium, A. So remember they told us that those are not the actual symbols of those elements. So we call it just A. Element A, we put 2 here. So 2, correct. 6H, 6, 3 times 2, 6. 6 chlorine, balanced. Well balanced. Well balanced. What is the mole ratio? Or the ratio? The ratio is 2 to 6 for the product and 2 to 3 for the reactant. So we are going to have 2 cancels. We are going to have 1, 2 goes here, 1, 2 goes here, 3, 1 to 3. And then we're going to have 2 to 3. That is the mole ratio. Let's continue. A reacts with 20, so volume is 20 cubic centimeter of dilute HCl. Calculate the molarity. Wow, what is molarity? Molarity is found by getting moles times 1000 all over volume. Mark this formula. Molarity, capital M, is gotten by multiplying moles times 1000 all over volume. Correct. So let's dive. Calculate the molarity. So let's go. We have gotten moles. No. So how do we find moles? Moles is equals to mass in grams over relative atomic mass. Good. So what do we have? We have mass as 0.081 gram over relative atomic mass. We are given 27. What is our answer? Our answer. Have your calculator with you. I have mine. Make sure it is cleared before you do anything. Mine is also already clear. 0.081 divided by 27. I get 0.003. 0.003 moles. Remember, these are moles for element A. Moles for element A. Are you getting that? Moles for element A. We are given the relative atomic mass to 27. So moles for element A is this one. So how about moles for HCl? Because they want the molarity of HCl. So because we have the mole ratio of 1 to 3. So if 1, remember 1 is for A and 3 is for HCl. If 1 for A is 0.003 moles, how about 3? So we come 3 times 0.003 over 1. What do we have? 0.009 moles. Yes. So we come and change 20 cubic centimeter to liters. Because the SI units must rhyme. They must rhyme. They must rhyme. I want you to get me clearly. We have to change this 20 cubic centimeter to either dm cubed or liters. So we know that 1 liter is equals to 1000 cubic centimeters. So how about or dm cubed? So how about how about 20 cubic centimeter? We're going to have 20 times 1 liter over 1000. What are we going to have? 20 times 1 is 20. Divided by 1000, we're going to have 0.02. 0.02 liters. So, calculation, we're going to have moles 0.009 times 1000 divided by 0.02. What do we have as our molarity down here? Remember I said molarity is equals to moles 0.009 times 1000 over volume 0.002. So 0.009 divided by answer 0.45. 0.45. 0.45 as our mole. And because we have already converted this 20, we are not supposed to multiply. That is a reminder. Or if we reach here, this 1000 is just converting this cubic centimeter. That's what I never saw. This 1000 is converting this 20 cubic already to what? To dm cubed. Are you getting that? To dm cubed or liters. Liters. So this is just conversion into liters. That is just the conversion into liters. So what are we going to have? since we converted just 20 cubic centimeters into liters, we can just multiply direct from our formula, because the formula says moles times 1,000, which 1,000, that 1,000 is directly converting cubic centimeter to liters by telling us that 1 liter is equals to 1,000 centimeter cubed. So there is no need of again coming back and multiplying by 1,000. That one is redundancy, and you'll get the answer wrong. So because we have the formula, let's just feed whatever we have direct. So we got moles, 1,000 is a constant, and volume we also have. So we come and write moles, 0.009 moles times 1,000 over 20 cubic centimeters. What do we have? 0.009 times 1,000 divided by 20. We are going to have 0.45 molar as our answer. Very nice. As simple as that. I want to tell you this. In moles, you should not have any problem. You should not have any challenge, so long as you have the formula. And look at what is lacking. When you are given this, what are you lacking? In this case, we are given mass, and we are given volume, and we are given relative atomic mass. We want to find molarity. Write the formula down. Molarity is equals to moles times 1,000 over volume. This 1,000 is a constant by showing us that the cubic centimeter is going to be converted into liters or dm cubed. We know that 1 liter is equal to 1 dm cubed. So what do we have over volume? Volume, we are given 20. 1,000 is constant. What do we lack? We lack moles. How can we find moles? We are given mass and relative atomic mass. As simple as that. So we find moles by checking, by converting, by calculating mass over relative atomic mass. That is moles in solid. Remember that particular substance is solid, element A. So we're going to find 0.081 grams over 27, and our answer is going to be 0.03 moles of A. They want the molarity of HCl. So we need to convert those moles of A by using the mole ratio. And what will give us the mole ratio is the chemical equation written up here. I began by saying A plus HCl give us ACl, A chloride plus hydrogen gas. When you balance the equation, these figures alongside the chemical symbols gives the ratio. And 2 to 6, A to HCl, is going to be reduced to 1 to 3. So when 1 is equals to 0.03 moles of A, how about 3 moles of HCl? That is what I did here and found 0.09 moles. So we already have moles. What next? Just feeding. Molarity is equals to moles times 1,000 over volume. We get 0.45 molar. Period. And the 3 marks. Next question. Next question. Under this, the periodic table question. Remember, paper 2, most of the internal exams will come periodic table. I'm not restricting you to paper 2, number 1. I'm not saying that it must be the periodic table, but in most cases, expect periodic table as question 1. Even in your KCSE, expect question 1 will come from the periodic table. I want you to put that in your brain, that question 1 will come in your periodic table. I'm not restricting you there, but always know that question 1 will come from periodic table. So a lot of periodic tables, if you want me to explain, elaborate, tell you more about the periodic table, kindly just contact us via the number up there. So let's dive to the last question of this periodic table. Remember how many marks we have garnered? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're going to the 13th marks. The graph below shows the trend of melting point and boiling points of the family to which G belongs. If you look at this question keenly, every letter within this particular periodic table we have tackled. So we are to the last one, G. Amazing. Explain the trend in melting points. Let's see the graph. So this is the graph. The graph. So we have fluorine, chlorine, bromine, iodine, astantine, astantine with a small t. That is the symbol, astantine. This one is also a halogen. Group 7 elements. Group 7 elements. Are you getting that? Yes, it is called astantine. That one. So we are seeing down the group, what happens? The melting point is increasing from 100, 200, 300 up to melting point is this one. This one is the one showing the melting point. So up to around 600. So the melting point is increasing. The melting point, the trend here, we are seeing that the melting point is increasing down the group. That is what we need to explain. So we need to explain by saying the melting point. This one was simple because we see it direct. The melting point of the element G. Explain the melting points. I mean, of the family to which G belongs. Oh, not G. The melting point, so just say of the elements. Of the elements. Increases down the group. What happens down the group? Now, then down the group, the number of energy levels increases. And when the number of energy levels increases, there is stronger nuclear forces of attraction. So that when there is stronger nuclear forces of attraction, the particles, for them to be broken down, there will be stronger boiling point and strong melting point. So this is because of increased number of electrons, increased number of electrons down the group, increasing the forces. In fact, these are halogens. So we need to talk about the van der Waals force. So the increase in the number of electrons increases or makes the van der Waals forces of attraction of those particles to be stronger. Are you listening to that? So as the number of electrons increases down the group, there is stronger forces of attraction. Van der Waals forces of attraction increases there. So we have said this is because of the increased number of electrons down the group, increasing the, leading to so my eraser is still erasing, leading to stronger van der Waals forces of attraction. Full stop. You earn the 2 marks. So the melting point of the element increases down the group. So we can easily see from the diagram that the melting point is increasing as we go down the group from fluorine to astantine. Down the group, the element increases. So there is increased number of electrons. As the number of electrons increases down the group, there are stronger van der Waals forces of attraction, and that is why the melting point also increases. increases. So that is the end of this question. That is the end of this question 1 of the periodic table. Thank you for listening to me, Teacher Zamalek. I'll be back with question 2. Bye-bye for now.